All right, guys, this is take 2 of recording this video. Let's hope it uploads this time. We are going to do 1.1D lesson on linear expressions in algebra tiles. We are not going to use algebra tiles today, though. So let's jump in. Emma is playing a popular video game and is determined to beat the high score. The game saves her place so that each time she plays it again, she picks up in the same place with the same number of points. Emma downloads the video game on Monday night and starts playing, scoring a bunch of points. On Tuesday, she scores an additional 500 points. On Wednesday, she doubles her total score from Tuesday. On Thursday, she scores the same number of points that she scored on Monday. Sam writes an expression that represents Emma's total score after she is finished playing on Thursday. Sam writes the expression 2 times p plus 500 plus p. Write in words what each piece of Sam's expression represents in the story. So P is just the number of points that Emma scores on Monday. So I'm going to write Emma's score on Monday. Then it says that on Tuesday, she scores an additional 500 points. So this next one is Monday's score plus Tuesday's score. So this is Emma's total score on Tuesday. The next one is on Wednesday, she doubles her total score from Tuesday. So it's 2 times that whole thing, not just 2 times P. So this is Emma's total score on Wednesday. And then the last one is Thursday, she scores the same number of points that she scored on Monday, which is just P. So we just add that P to this number of points she scored on Wednesday for Emma's total score on Thursday. Beth writes the expression 2p plus 1,000 plus p to represent Emma's score on Thursday. How did Beth represent this problem differently than Sam? So we're saying, how is this different from this? And all that Beth did was just distribute that too. So if I wrote Sam's expression, Beth took Sam's expression and she distributed the 2 to get 2p plus, I'm sorry, not 500, because you need to distribute this 2 to both. So 2p plus 1,000 plus p. So I'm going to say this, she distributed. Write another expression to represent Emma's score on Thursday. So another expression, we could just combine like terms. My like terms here are 2p and p. So I could write 3p plus 1,000. Substituting a specific number for the unknown in this expression and calculating the resulting value is called evaluating the expression. This is important because your homework and future lessons are going to ask you to evaluate expressions often. So if Emma scored 700 points on Monday, evaluate each of the 3 expressions above to determine how many points Emma has on Thursday. So first, we're going to write the expression from part A. I'm going to get a little bit of a darker color. So part A just had 2 times p plus 500 plus p. And then we remember that Beth distributed that 2. So she got 2p plus 1,000 plus p. And then this should actually say the expression from part C. This is just 3p plus 1,000. So now when it asks us to evaluate just means to substitute or plug in the given value. So again, we should be taking these notes in our module while I'm doing this as well. 700 points. So I am going to plug 700 in wherever I see my value of p. So right here, right here, right here, right here, and right here. And then I'm going to go back and rewrite the rest of the expression. So I have 2 times 700 plus 500 plus 700. And if I were to solve this, it would be 700 plus 500 is 1200. 1200 times 2, I can get 2400 plus 700. This will get me 3100. When I finish solving this one, I'm going to rewrite the rest of the expression first. 2 times 700 is 1400. And then I can do 1000 plus 700 is just 1700. If I were to add those together, I would get 3100 again. And this last expression, let me move my video here because I'm realizing that my face is in the way. Okay, if I were to finish out this part C, then I would have 3 times 700, which is 2100, plus 1000, which is again 3100. So it asked us, what do we notice? Well, all of these are the same. That's going to happen when we have equivalent expressions. Which expression is the most efficient to evaluate, and explain why? So for part E, I'm going to write the same answers. The most efficient would be this one. And this one is already simplified. So part C is already simplified. It's going to be a lot easier to evaluate for an expression when it is already in simplified form. So that's page 1. We are going to move on to page 2. And it says, for Emma's situation, the expressions 2 times p plus 500 plus p and 2p plus 1000 plus p and 3p plus 1000 are equivalent linear expressions. Expressions are considered equivalent when a substitution of any number for the unknown in each expression produces the same numerical result. Algebra tiles can be used to model and simplify linear expressions. We are not going to do algebra tiles in this lesson, so we are going to skip those parts. If algebra tiles help you, though, and you know how to use them, go for it. You are absolutely allowed to use algebra tiles, but you do not need to. So we are going to skip this part, but we're just going to simplify this expression in number 2. So when I simplify, I like to kind of know what are my like terms. So I have a 5x and a negative 3x, which I can combine, and I have a negative 6 and a 4, which I can combine. So 5x plus negative 3x would just give us 2x. Negative 6 plus 4 would just get us negative 2. You could also write it as 2x plus negative 2. This one is the more simplified expression, though. It's going to now ask us to evaluate for 8. Remember, when it says evaluate, all I'm doing is, this is my expression. Instead of 2 times x, we're just going to say 2 times 8. The rest of the expression is the same. So now this is 16 minus 2. This is going to equal 14. Okay, moving on to number 3. Again, we're not going to model here. So we're just going to combine like terms to write the simplified form of the expression. So this would be a really good time to pause the video and try it yourself, and then come back and check your answer. Okay, so we are going to combine like terms. Negative 4x and 5x will just get us x. 3 plus negative 1 will just get us 2. When I'm going to evaluate this for x equals negative 5, I'm just going to plug in negative 5 for x and keep the rest of the expression the same, and that will equal negative 3. So this last part down here says the algebraic expression 3 times x plus 1 equals 3 times x plus 3 times 1, because we would distribute this to both terms. That simplifies to 3x plus 3. This is an example of the distributive property. The distributive property is an algebra property which is used to multiply a term and two or more terms inside a set of parentheses. 3 times x plus 1 and 3x plus 3 are equivalent expressions. So moving on to page 3, again, we are not going to be using algebra tiles. So we're just going to be solving A and B in these. So in part A, it says, write the simplified form of the expression. I cannot do anything in the parentheses because I have a variable and a number. So I'm going to distribute to both terms and write 2x plus 4 minus x. Not quite simplified yet because I have some like terms that I can combine. I could combine 2x and a negative x. So this is just x plus 4. In part B, it says, evaluate for x equals negative half. Show all of your work. Remember when it says evaluate, we're just plugging in. So instead of x, I'm just going to write negative half plus 4, keep the rest of the expression the same. So in my head, I can already know what this answer is. This answer would be 3.5. So I know that I'm going to get 3.5. If I want to show the steps of adding and subtracting fractions, say on a test or in homework, like you're going to show all of your work, it's negative half plus I need to make my denominator the same. So I have to think how many halves are in 4. There would be 8 halves in 4, and this would be 7 over 2. In this class, you can keep your answer as an improper fraction just like this. It's actually going to be easier when we get to slope. Okay, next one. Write the simplified form of the expression. Again, I cannot do anything in the parentheses, so I'm going to distribute this 4. So I'm going to keep the rest the same. And then I have 4x minus 12. Don't forget to distribute to that second term as well. Now I'm going to combine like terms. I have a 4x and a negative 3x. That's going to get me an x. And I have a 3 and a negative 12. This is going to get me a negative 9. Now when I evaluate, I'm just going to plug in x equals 10.4. So instead of x, I'm going to write 10.4 minus 9. And that's just going to get me 1.4. Number 6, is the expression 3 divided by 0.05 simplified? Explain why or why not. Well, when we see a fraction and there is a decimal in it, we should know that this is not simplified. So I'm going to say no, because there is still an operation that can be done. So 3 can actually still be divided by 0.05. The way I like to think of this is if I have $3 and I'm trying to divide them into nickels, how many nickels would that be? So if I have $1 and I divide it into nickels, nickels are worth 5 cents. That's why I'm using this. I know I would have 20 nickels. If I have $3, that would be 60 nickels. So 3 divided by 0.05 would be 60. Another way to do this is you could move the decimal place 2 places to get 5, but I would have to move the decimal places 2 places at the top to get 300. 300 divided by 5 is 60. We're going to learn a little bit more how to do this later on, but please know if there's a fraction with a decimal in it, it's not yet simplified. We are actually going to skip number 7 because we're not going to use algebra tiles in this one. And for 8 and 9, it says simplify each expression without using algebra tiles. Use the simplified expression to evaluate for the given value and classify as a natural, whole, integer, or rational. You can also classify as more than one. So for number 8, I can't do anything inside the parentheses. So first thing I'm going to do is to distribute. I will get a 10x plus 5, and the rest of the expression stays the same. So I still have a negative 4x plus 3x minus 8 plus 10x plus 5. Now I'm going to combine like terms, and I see that I have this negative 4x, this 3x, and this 10x. So I'm going to first do negative 4x plus 3x. That will just get me a negative x plus a 10x. Then I'm just going to rewrite this negative 8 over here and this plus 5. You don't have to rearrange it. It just helps me see them next to each other so that I know what to combine. So the simplified expression, now I can combine the negative x and the 10x. This is just going to be 9x. And the negative 8 and the 5, this is just going to be negative 3. So now I have to evaluate for when x equals 2/3. And they are actually making this a little bit easier for you because they are having you go in order and simplify first and then evaluate. It's going to be a lot easier to evaluate this simplified expression. Please remember that. Don't just try and plug in whatever is given to you in the expression unless it is simplified. So when I plug this in, it's 9 times 2/3 minus 3. And I can see that 9 times 2/3, it's going to be less than 9. So I should just remember that when I'm multiplying this fraction times this number. I know that 3 goes into 3 once, and 3 goes into 9 3 times. So now I'm just going to have 3 times 2 over 1, or 6 minus 3, which is just going to give me 3. If I am going to classify this as a solution, I'm going to classify this number. So this number I know is an integer. I also know this number is a whole number. I also know this number is a natural number. And 3 could also be a rational number. If I write it as 3 over 1, that's still a fraction. Okay, just pause briefly for the train there. Sorry about that. So we are coming back and we are looking at number 9, and there's no subtraction sign in front of these parentheses, which means I don't need to distribute the subtraction sign. So I can actually just get rid of those parentheses and rewrite this without them if I wanted, or I could even just rearrange 2x plus 4x plus negative 3 plus 7. That's actually the same thing as the other one. Just makes it a little bit easier to combine. So 2x plus 4x, this is going to give me 6x. 7 minus 3 will just get me 4. Now I'm going to evaluate for when x equals negative 2/3, which means I'm just going to plug this in. Instead of 6 times x, it's 6 times negative 2/3. Everything else stays the same. So now I'm looking at how can I simplify 6 and negative 2/3. I know that 3 goes into 3 once. 3 goes into 6 twice. So now I just have 2 times negative 2, which is just negative 4. And then I have, this should actually be a plus 4, guys. 7 plus a negative 3 is actually a plus 4. So this is plus 4. So now I have negative 4 plus 4, and that will give me my answer of 0. When I classify this solution, 0 is a whole number. 0 is also considered an integer and rational. Whole, integer, rational. And then for this last part, we're just going to do a couple more problems. So number 13 is what we're going to start with. If I look at this, there's nothing I can do inside the parentheses, so I first have to distribute. And just make sure when you're distributing, you are distributing that negative 2. So this becomes negative 4x. Negative 4 times negative 7 will become plus 28. And then the rest stays the same, plus 10 minus 5x. Now I can see that 28 plus 10 will be 38. And then I have a negative 5x and a negative 4x. This is going to be negative 9x plus 38. Number 14, there are a lot of negatives, which is why I chose this one, because we have to be very careful when we're distributing negative to both terms. We have to first distribute it to both terms. Sometimes we forget that second one. And we have to make sure to change it to a plus sign. So in this case, we're not just distributing the 5, we're distributing the negative 5. We're also going to distribute this negative to the negative 12. So let's start here. Negative 5 times 3x will give me negative 15x. I'm going to keep that negative 10 the same. Negative 5 times negative 1 will get me positive 1. Now negative times negative 12 will get me just the plus 12. So now I only have one term with x in it. So I'm just going to go ahead and write that first, negative 15x. And then I have a 5 plus 12 is 17, minus a 10 is just going to be 7. So negative 15x plus 7, and one last fraction example. So 12 gets distributed to both of these, 12 times 1/3 x and 12 times 2. So I could do 12 times 1/3 and do 12 divided by, and see what 1/3 of 12 is. It's the same thing as saying 12 divided by 3. So this is just going to be 4x. 12 times 2 is going to be 24 plus 5. So I have 4x plus 29. And that is it for 1.1D lesson. So now you guys can go ahead and go start that homework.